Right. So, as promised, the assignment, if you want to call it that, really consists of some worksheet questions. The worksheet that you have, and then some previous worksheets that I did have also on this topic. So, excuse me, this first question, we saw it on the worksheets last week, and I did tell you that if you consult the text, which it's posted twice on Moodle, it's posted once on their announcement, and then I reposted again on the probability yesterday. And so you will find guidance on sampling without replacement, finding probability when you're sampling without replacement, because in that case, the probabilities do not remain the same. Every time you take one and you don't put it back, the probability of getting a red ball or a yellow ball will change every time you take one and you don't put it back, because the bottom number keeps changing, the less balls remaining in the box. And so that one will just require you to do some reading, but it's not a difficult question. And then this other question 2, we did also go through this last week. And so you see that there are 150 jelly beans. A jar of 150 jelly beans contains 22 red, 38 yellow, 20 green, 28 purple, 26 blue. The rest are orange. So event B, the event of getting a blue, event G, the event of getting a green, O orange, P purple, R red, Y yellow. So the probability of B would be the number of blue jelly beans divided by the total number of jelly beans. And the same would apply for all of the other colors that you see there. The event probability of G would be the number of green jelly beans out of the total 150 jelly beans. So that's for that question. It doesn't require you to find any or and or anything like that, just straightforward the probabilities there. And then you have one question here on the discrete random variable and its probability distribution. And as we saw in the last class as well, I'll work a question on this for you tonight. As we saw, you have x, which is the values that your random variable can take on, and you have the probability of x. And so you have to find the mean and standard deviation for this distribution. We know that the mean you will find as the sum of x times probability of x, and then the standard deviation is the square root of the sum of x squared times probability of x minus the square of the mean. And so again, not too much complicated calculation. So you ask to find the mean and standard deviation and then give a brief interpretation of the value of the mean. And then the other two questions are fairly similar in nature. One of them asks you to draw a tree diagram, question 4. So you have a group of people, some are in favor of a tax increase on rich people, and then the others are against it. Assume there's no other outcome, such as no opinion or don't know. So there are just two outcomes, either in favor or against. 3 persons are selected at random from this group, and their opinions in favor or against such taxes are noted. Now think about this as flipping a coin 3 times, because there are only 2 outcomes that are possible here, in favor or against. Same thing, if you're flipping a coin, there are only 2 outcomes, heads or tails. And so the way I showed you to construct the tree diagram for the coin flip is pretty much the same that you will apply here to construct the tree diagram for this experiment. And then the last question, fairly similar. You will draw a tree diagram, and then from your tree diagram, remember the tree diagram will allow you to list all the outcomes in your sample space. And then you would be able to say which of these events below are simple and which are compound events, and then list all the outcomes included in each of the following events. So the event that one person has an iPad, and one person does not. So one has a one. In this experiment, some people have iPods, others do not. So again, only two outcomes. Either you have one or you don't have one. Two adults are randomly selected. So again, this is like flipping the coin two times. How many total outcomes do you expect when you flip the coin two times? We went through an example like that. And then you list out what those outcomes are. One outcome will be that both people have, another outcome will be that both people don't have. And then you will have other outcomes in between. The other two outcomes in between. So at least one person has an iPod. How many outcomes are included there? We know what at least means by now. And then not more than one person has an iPod. Again, not more than one. What does that mean? As you'll be able um, to count that. And then the first person has an iPod and the second person. Just note the difference between A and D. A is saying one person has an iPod and the other does not. It's not saying which does and which doesn't. But D is very specific. It's saying the first person has one and the second person does not. And so bear that in mind when you're asking me, because part A and part B are not asking you for the same thing. So those, I heard the waiting room, but there's nobody. Right. So those are the pointers I can give you for now regarding the assignment. If it is that you have other questions after going through it, then you can bring those to the tutorial next week, so, or Saturday. So remember, I can't solve the questions for you, but if you have a problem with interpreting the question, that I would gladly assist with. So once you are able to go through Twitter groups, then you can decide whether everybody understands what the question is asking them. And if you are having certain differences of opinions and you just want me to settle an opinion for you, then I can help with that. So, but are there any questions based on what I've said so far?
No.
Okay, great. So I will stop this recording now.